This lesson shows how to solve disjunctions, compound inequalities joined by the word or. Solve disjunctions by solving each of its two parts. On the left, you have 3x minus 1 is less than negative 10. Add 1 to both sides for 3x less than negative 9. Then divide both sides by 3 for x less than negative 3. On the right, you have 3x minus 1 greater than 5. Add 1 to both sides for 3x greater than 6. Then divide both sides by 3 for x greater than 2. So the solution for this disjunction is x less than negative 3 or x greater than 2. What this means is that any number less than negative 3 or greater than 2 will make the disjunction true. Graph the solution to verify that it makes sense. The left-hand inequality must be less than, and the right-hand inequality greater than. The number on the left must be smaller than the number on the right. There are two boundary checks. On the left, write the inequality as an equation and substitute the left boundary, x equal negative 3, for 3 times negative 3 minus 1, which is negative 9, negative 1, which is negative 10, and the left boundary checks. On the right, write the inequality as an equation and substitute the right boundary, x equal 2, for 3 times 2 minus 1, which is 6 minus 1, which is 5, and the right boundary checks. There is also an inequality check. Since any value less than negative 3 is a solution, use a value like x equal negative 4. Substitute into the inequality for 3 times negative 4, negative 1, which is negative 12, negative 1, which is negative 13. Notice that the left-hand statement, negative 13 less than negative 10, is true, while the right-hand statement, negative 13 greater than 5, is false. However, because of the word or, if one part of the statement is true, the entire statement is true, and the solution checks. You can also do an inequality check on the other side. Since any value greater than 2 is a solution, use a value like x equal 3. Substitute into the inequality for 3 times 3 minus 1, which is 9 minus 1, which is 8. Notice that the right-hand statement, 8 greater than 5, is true, while the left-hand statement, 8 less than negative 10, is false. However, because of the word or, if one part of the statement is true, the entire statement is true, and the solution checks. Remember, when you write the solution to a disjunction, the left-hand inequality must be less than, and the right-hand inequality greater than. The number on the left must be smaller than the number on the right. It's important to graph your solutions to verify that they make sense. For example 1, this solution is written backwards because the greater than inequality is written first. If you flip it around, you have a good statement. All the numbers less than -1 or greater than 4. For example 2, this solution is all real numbers. To see why this is true, graph the disjunction x less than 2 or x greater than -4. The graph of this disjunction includes the entire number line. So the solution to this disjunction is all real numbers. This lesson has been brought to you by the Math Department of Moreau Catholic High School, the Holy Cross School, bringing hope, building respect, being family, educating hearts and minds.